Hey everyone, in this video I'm going to be showing you how to build a Lumenier QAV210. This is a really fun frame to fly and to build. The major difference between this frame and the QAV250 is that this one's a 210 millimeter from shaft to shaft, and the QAV250 is a 250 millimeter. So this one built as is about 320 grams versus the 250, which is about 360 grams or something like that. So this one's gonna have a better power to weight ratio, and because of the size, when you fly it, it feels a lot more nimble and agile. And then another difference between this one and the 250 is that this one, the ESCs are mounted on the arms, whereas the QAV250, the ESCs are mounted on the bottom with a power distribution board. But having the ESCs on the arms are going to make building a lot easier because you have access to the power distribution board and the motors right here. So as you can see, I've already built one here, and I've built about 10 of these. So I've made these little cheat sheets available. They're gonna come with the kits that are gonna be available on my site. It shows you how long you need to cut all the wires for everything on the quad, so it's gonna make building these a lot easier. And I also show you how to build the quad if you're not using the cheat sheet. In the method I'm showing you how to build here, you can use to build the QAV210, the QAV180, and the new race blades. Because the race blades, the frame is basically the same thing. It's got, the same top plate. It's got basically the same bottom plate. The only difference is that the race blade has removable arms, whereas this one doesn't. So this frame is going to be a little bit lighter than the race blades. First, we'll just go over the parts that we're going to be using. In this frame, I'll be using the XM20. The DYS XM20 ESCs. Let me see if you can see that. So these are the new ones from DYS. These are the XM20. These run with the Silicon Labs microprocessor, and they run at a 50 megahertz operating speed. So that means it can handle much faster KV motors, and it's kind of like raising the red line in your car. So there's no limit on how fast the KV on the motors can run. So it'll make your motors it can draw a lot more power out of the motors, even if you're using same motors versus some of the older ESCs. You can use, basically for this setup, you can use any 20 amp opto ESC. Opto just means that the ESC doesn't have a built-in BEC. You can run the older DYS BL20s. These are very similar to the XM20, except the XM20s have a BL Heli bootloader, where the BL20As are Simon K bootloader flashed with BL Heli firmware. And the operating these run at like 16 megahertz or something. So the new XM20s are gonna perform a lot faster than the older BL20s. Or you can run these FVT little Bs. The specs on these two ESCs, they're very similar. They both run Silicon Labs. They're both running BL Heli, I think 14.3, which is the most current version as of this video, and they're both dampened light and one shot and all that good stuff. But I decided to go with the XM20s because they have this V1 and V2. So they have two versions. The ESC itself is the same, except the V1s, they don't have the motor wires already soldered on here like these FVT little Bs. So that's just gonna make save one step in our build. Plus these are new, and I just built one on here, and they're pretty awesome. So you can't go wrong with any of these 3 ESCs. And then for the motors, I'll be running the, I don't know if you can see it, but these are the Cobra 2300 kV motors. I was trying to get my hands on the new Emax RS 2250 2300 kVs, but they're not released yet. But later on, I'll be making a video of comparison of the Cobra 2300 kVs versus the Emax 2300 kVs, because I've heard a lot of good things about them. But you could basically run any 2300 kV or even a 2100 kV motor like the Cobras if you're gonna run 4S. So on my setup, I'll be running 3S. So a 2300 kV motor will be plenty for this setup. And then on this setup, I'm running the Lumenier 5.8 gigahertz 32 channel race band 600 milliwatt transmitter. Since this frame is so small, it's probably best if you use one of these smaller transmitters in here. You can either run this Lumenier, or I'll be trying these little Bosscam 5.8 gigahertz video transmitters. These are both 5.8 gigahertz 32 channels, except this one's 600 milliwatt and this one's a 350. If you're running in a country that doesn't allow the 600s. So all 3 of these transmitters, they're very similar in size, except the Bosscams are a little bit thicker than the Lumeniers. But they all essentially do the same thing. I've been using this one in my my tweaker quad, and it works. It works really well. Just one thing you have to be careful on these the Bosscams. The antenna takes a RP SMA. I don't know if you can see that, but the connector is different on this one versus the Lumenier, whereas it just takes a regular SMA connector, like on these black Fat Sharks. I'll try to get a close up for you to see. I don't know if you can see that, but the connectors are a little bit different. So just be careful when you're picking out your antenna. Okay, in this frame, I'll be running the newest or the latest revision of the NACE 32 board as of this recording. This is a revision 6. It's a revision 6B NACE 32. This one, the pin layout is very similar to the revision 5, except the inputs on the revision 6 are now all in a 10 pin straight setting. So whereas the old one, it was a 5 pad on double sided, but this one's exactly the same. You're going to have ground, power, signal for channel 1, 2, 3, 4, 5, 6, 7, 8, and then you got all your input leads for the ESCs 1 through 4 here. And then this will be your VBAT and then buzzer here. The biggest change or biggest physical change on this board is that they moved the where the USB connector is. Before on the revision 5, the USB used to line up with the OSDoge board. You can see right here. Now it doesn't line up. But I'll show you how to connect it, just like you know, the other boards. It's not that hard. And then let's see what else. Yeah, and this one I'll be running the OSDoge board again. The OSDoge is gonna be since our ESCs don't have a BEC, we'll be running this board to power our NACE 32 using the 5 volt from the OSDoge. And then it'll be our LC filter for the video camera part also. And then we'll be running the FreeSky D4R2 running in PPM mode. I've got mine mounted on this custom D4R2 mount right here. It's just gonna sit on the standoffs right here and kind of float in the middle because this frame is so small. This is really the only place you can mount it, unless you're gonna put it on top, but then I don't like having anything outside the cage. And the camera will be a 600 TVL HS 1177. It's basically like the other 600 TVL cameras I run with the Sony Super HAD chips, except this one will just be in a case. Okay, so that's basically a rundown of all the parts we're using. Also I'm using these motor guards right here, custom motor guards. Ever since I've started using these on all my quads, I haven't lost any motors, so that's pretty sweet. And I've smashed into some trees pretty hard. Okay, so let's get on with the build. Okay, so this will be the basic diagram for the QAV210 build. As of January 12, 2016, this is the most recent, most up-to-date version of the NACE 32. This is the NACE 32 revision 6B. As you can see, all the pins are pretty much the same as the older NACE 32s, except the biggest difference is that the receiver pins are 10 pins straight instead of the old ones where it was five pads on each side, double-sided. So you're still going to use the same inputs for hooking up your D4R2 or your receiver. It's just going to be negative, positive, and then signal to the negative, positive, and signal on the D4R2. You're going to use the top pins for channel, or top row pins for channel 1. And then we're going to be running this one in PPM mode. So PPM is basically, it lets you output 8 channels just using one wire on this signal right here, instead of hooking up 4 separate, or actually the D4R2 is actually only a 4 channel if you run it the conventional way. But to run this quadcopter, we're gonna need about 6 channels, 4 for flying, 2 for 1 for modes, and then 1 for the arm and disarm and buzzer. So to get PPM, just make sure you put your black jumper cable across the signal leads on 3 and 4, or you do the other method where I'll show you in the video, where you put a solder bridge on these two leads. Okay, so we'll be using the XM20 ESCs. The XM20 are opto ESCs, meaning they don't have a built-in BEC. BEC stands for battery eliminator circuitry. So usually on the older type of ESCs, they're a lot bigger, and they come with a BEC, meaning they have a next to the signal wire, you'll see a black and a red. So that black and red will connect right here to ground and positive, and that'll supply the 5 volts you need for the NACE 32. But that's kind of redundant because you only need 1. You don't need 4 ESCs with BECs on them. So that's the good thing about the opto ESCs. They're a lot smaller and they're more efficient for using the power you give them. So the power for the NACE 32 is going to come from right here off the OSD board, OSDoge. It's when you stack the boards together, that's what these red dots are. When you put them over on top of each other, this part is going to connect here. TXRX is going to connect here, and then the ground and power 5 volt is going to connect right here on channel 6. And then this TXRX will allow you to do any changes in your OSD, set up anything, any of the displays, or change your PIDs from your goggles instead of needing to connect it to the USB to change any of your PIDs. So right here, on this diagram, I'm not showing you the power distribution board, but basically the power distribution board, all it does is distribute the power from the positive to all the positives that need battery positives, and then the negatives to all the negatives. So you can see here the ESCs are connected directly onto the positives, positive, positive, positives, and then negatives are on the negatives here. And then the other part that you need to connect from the battery is right here, VBAT, ground, and the battery right here. So if you're not using the OSD board, you would put VBAT right here. This is ground and this is power. But then you can see right here when we stack it, it'll connect it to the VBAT. So the VBAT is for monitoring your battery level. When you're flying with the OSD, I'll show you how to calibrate the OSD to show how much battery you have left in the battery, and then we'll also set up a low battery voltage warning on the OSD where it'll start flashing, and then we'll set it to where the on the buzzer on the NACE32 will start beeping when you reach below a certain threshold. So you'll know to land your quad, because these lipos, once it reaches that low battery, it's gonna drop really fast. What else? Okay, and then the OSD board is gonna have a built-in LC filter. So basically, the LC filter just cleans up the power from the battery before it goes to the camera and the transmitter, because when you're running these motors, it's gonna have a lot of a noise, like power spikes and all that stuff. So if you don't have an LC filter and you run your camera and VTX directly off the battery, your picture is gonna look like crap. There's gonna be junk, like static and all sorts of lines all over your screen. So what the LC filter does, it cleans up your picture, so you're gonna have a much smoother looking picture. And then we'll just be using a HS1177 12-volt camera running off the Lumenier 5.8 600 milliwatt transmitter right here. So I'll show you how to hook all that up in the video. Okay, so this is how we're going to mount the NACE32. If you look right here, you can see this little arrow right here is pointing to the back. That means we're going to mount the NACE32 backwards 180 degrees. If you mount the NACE32 any other way than with the arrow pointing forward, in a clean flight, you're going to have to adjust the yaw adjustment, and I'll show you how to do that in part 2 of this video. But this is how we're going to mount the NACE32. We're going to have it facing back, so that way we have easy access to the USB on the right. And the reason why we do that is because when you stack the OSDoge board on top, it's going to stack like this. You're going to have all your camera and VTX cables pointing forward, and that'll be easy to connect to the camera. And then when you have it like this, the OSDoge USB is going to be pointing to the front, which is kind of hard to access. But once you configure your board during the setup process, you probably will never need to use this USB anymore. So I gave priority to the USB on the right for the NACE30, or on the left, because I feel like this way you're going to be using the USB a lot more than this one. So this is how we're going to stack up the NACE32. Okay, so the first thing we're going to do is we're going to mount the PDB, power distribution board, onto the frame. So we'll just kind of quickly go over the power distribution board. This is the one that came with the frame. It's the Lumenier 4 Power. You can see right here it's got paths for the battery right here, plus, negative, and then ESCs. But don't pay attention to the labels right here, because on this board it's showing you ESC 1, 2, 3, and 4. That's the setup for a CCD flight controller, but we'll be using the NACE32. So the NACE32 is going to go ESC 1, ESC 2, ESC 3, and then ESC 4. So it's a little backwards on this side. And then it's also got a little little spot right here for a step down converter. That's if you're if you're not using the OSDoge board, you would put like a little converter right here, and these pads, these auxiliary pads, are for this one. So if you're gonna use, if you're just wanting battery power, you're gonna use auxiliary 1, not auxiliary 2, as you can see right here, because unless you put the step down converter, there'll be no power here. So we're just gonna use these little included they look like 6mm standoffs, but instead of the plastic screws that it came with, I'm going to be using M3x8 screws, just so I can mount this board flat on the frame. As you can see on the back right here, it's got a little cutout in case you have this little step down converter, so it can sit flush. But since if we mount it flush like this, the leads, it's not going to touch the frame. If you're going to use the step down converter, then you'll need a little standoff to put in here before you mount your board. But the way we're going to do it is we're just going to use these little M3x8 screws, mount it this way. And then the reason why I'm showing you this is when you mount these like this, you don't want to over tighten the screw. This is something I kind of found out the hard way. It seems like the new NACE32 boards are very sensitive to vibration. So if you have these screws too tightened too much, you're gonna get a lot of vibration in your NACE32, and then it's gonna have this weird drift where your quad will fly. It'll take off normal, and then slowly it'll eventually like develop a drift going one way or the other, and you can't correct that in clean flight. The only way to prevent that from happening is this is the way I do it. I just put my screws through here, and then I'll get some like blue Loctite or something. I'll put a little dab right here, and then you can use like a zip tie or something and just put a tiny bit on the screws, or you can put it on the screw before you put it in the hole. I don't like to dab Loctite directly onto the screw, because then it's super messy. So just make sure you mount, this is the front of the quad right here, make sure you mount with the battery pointing to the rear of the quad. So I'm just going to screw these on lightly, just like very, very lightly. And then I'm just going to do the same. Just put a little bit of Loctite on this screw, and then just put it through the hole. And then just do the same for all the other ones. But the key here when you're mounting the power distribution board with the nylon standoff, don't over tighten these, because then you're gonna, I'll show you what this weird drift I'm talking about later. So next we're just gonna prepare the ESCs to be mounted on the power distribution board. All I'm gonna do here is I'm gonna remove the factory heat shrink off the ESCs so we can remove the signal wires off the ESCs. Just gonna pull this off and just remove the signal wires just like that, and then just gonna put these little wires to the side because we're gonna use them later. So just do that to all of them. So after you've removed all your the heat shrink and the signal leads, you should end up with ESCs that look like this. Just the ESC with the power lines on it. And then next you're just gonna kind of lay the ESCs position where you want them, and then you're just gonna measure out how much cable or how much power wire you need, and then just get some wire cutters and cut it for the length you need. Just make sure you put the negatives to negatives and positives to positives. But I'm not gonna cut it like this. I'm gonna use the little cheat sheet I made, because I have these measured out exactly to how long you need. for ESCs 1 and 4, 2 and 3. So I'm going to cut 2 over on this length and then 2 for this length. So this is going to be my ESC 1. So I'm just going to measure it like this. Right there. And then for the negative, like that. And then I'm just going to cut the rest for the other ESCs. So before you can solder the ESCs onto the PDB, it's a good idea to pre-tin the wires, because that'll make your the solder job a lot easier. To do this, I just touch the wire and then just put a little bit of solder right there, and then just make sure the solder heats up the wire enough to melt the solder, because you want the solder all throughout the strands of wires. You don't want it to just coat the outside of the wires, because that's not tinning. Okay, so now that I have all the ESCs prepared to be mounted on the power distribution boards, I've got all the wires cut to the appropriate lengths, and I've got the tips pre-tinned. I can mount them on the PDB. One good thing about the XM20 is that the motor connections, they're good on both sides, so it doesn't really matter which way you mount the ESCs, because you can solder the motors on either side. But we're gonna mount it the way that we cut the wires. So for ESC 1, you know, the negative lead is gonna be the shorter one, and then positive is on the right. Okay, now so we can start soldering the ESCs onto the power distribution boards. It's always a good idea to pre-tin your power distribution board before you solder the ESCs on. So I've got my soldering iron at about 745 degrees or so. So I'm just going to pre-tin the leads a little bit. So I'm just going to show you one of them. So I'm going to grab the lead and then just touch it. So when I solder this, it's the same concept. You're just going to touch the pad and the solder, I mean the ESC at the same time, like that. I just do it enough to melt it, and then I kind of hold it down right here at the wire, not at the tip, because when you do that and the solder melts, it's going to flatten the wire. So just do right here and just lightly touch until it melts. And you want a nice shiny solder joint. You don't want a bumpy one, and that means it's not a good joint. So once you're done, it should look something like this. So you're just going to do the same to all the other ones. Okay, so once you've mounted your ESCs onto the power distribution board, this is what your quad should look like. Get the wires like that, and then once you put the heat shrink on, they'll sit kind of like this, and then we'll mount the motors and put the motor wires right here. So next we're just going to prepare the wires for the ESC signals. So you're just going to take the little wires you took off the ESCs earlier and just remove them from the little plastic housing. To do that, just get some sharp and pry the little thing up, and then you can pull the wire out like this. Ugh, come on, like that. Okay, and then pull the wires apart. Okay, so after you've got the wires apart, you should end up with 4 cables and 2 of these 3-pin connectors. We're gonna need to make a 4-pin harness for the NACE32. So if you don't have one of these 4-pin housings, these will be included in the kit. You can take these 3-pin housings and just take a knife and cut one of them off. So that way you'll end up with 2-pin housings, and then just put 2 pins in each. But for mine, I'm going to use this 4-pin harness, and then I'm just going to plug it in, alternating. It doesn't really matter what color wires you use, as long as you connect them to the correct ESCs. I'll show you how to do that later. So you end up with a 4-wire harness. Okay, so next we're just going to prepare the NACE32 with all the header pins. So I'm just going to use this 1x4 90-degree header for the input leads for the ESC. So I'm just going to mount it upside down on the bottom of the NACE pointing in. I found that's the easiest way to have a clean build without a whole bunch of wires sticking out all over the place. So it doesn't matter if the headers are crooked or whatever. The way I do it is I just tack one in, and then you can you can lightly pull on the header pin, and I mean very lightly, just enough to, like, if the solder wasn't there, just to move it. So lightly you're gonna pull on one side and then just tap this joint that you just made, and then that'll be enough to just give it enough clearance right there so you can put the header on. And then I'm gonna put on a little 2-pin 90-degree for the buzzer, and I'm gonna put this one pointing in. And again, it doesn't matter which way you do it, just tack one on. And then I always like to make it make sure it's away from the TX RX a little bit, so it's easy to plug in. So same thing, you're just gonna kind of move it a little bit with your hand, but make sure you're not touching the one that you're gonna be soldering, because it'll get super hot really quick. So that's it. So you can see it's a little bit off to the side. And then once I have the headers in the positions that I want, I'm just going to use my clamp here and then just kind of solder everything else in place. And then I'm going to put on a little 2-pin or 3-pin wire connector, servo connector for the receiver. So I've already, I don't know if you can see that, I've already taken off a little bit of the wire, and I'm just going to put it through the first 3 pins on this 10-pin. So it's going to be ground, 5-volt, and signal. So I'm just going to pull these off. So that's pretty much it for the soldering on the NACE32. The only other things we have to solder would be the male-female pins, and we'll do that when we're setting up the OSDoge. So now we're going to measure out the amount of wire you need for the signals on the ESC. So the way you do that is make sure you have your NACE32 pointed the direction you're going to mount it, and then connect your 4-pin connector, or if you're using the 2 pins, just connect all the wires up into it, and then make sure you have signals 1, or the signal 1 connected to ESC 1, signal 2, 2, 3, 3, and then 4, 4. So you just kind of arrange the wires out in the direction that you need. Just say it's like this, and then you're just gonna mount your NACE32 like that, and then you're gonna measure out how much wire you need, and then you'll just cut it and solder there. That's the method you're gonna use if you're not using this cheat sheet. So I'm gonna show you the other way. Okay, so if you're using the cheat sheet that comes with the kit, this is how you're gonna measure your wires. It'll be the easier way. You're just gonna measure ESC signal wires 1 and 3. This will be 1 and 3. Well, actually, I like to put the kind of color code on. It doesn't matter what color you use. It's just whatever makes it easiest for you to remember which ESC wires go where. So the length of these lines represent the amount of wire you need, not including connectors. So it would be just like this, not at the tip of the connector, but just the wire part. So we're just gonna measure it like this. So this would be ESC signals 1 and 3, and then I'm gonna cut 2 and 4. I know a lot of this stuff that I do is kind of unnecessary, and all this exact measuring and everything, but this is what you have to do if you want a clean build. This is my OCD effects coming in, as you can see from my neat little cheat sheet. Okay. Alright, so now you have the exact amount of wire you need for the ESCs. So you're just going to splice these and then just solder them onto the ESCs. Alright, so here's just a quick little tip for soldering these tiny little wires onto the ESCs. When I do it, I don't put the soldering tip on the little wire here, because these wires are so tiny. If you put too much heat on them, it'll just destroy the wire. So what I do is I put heat on this little solder pad, and when it's melted, I just push this one in. And that's it. Okay, so now that we have the ESCs mounted on the power distribution board and all the ESC signal wires cut to the correct length, we can put on the heat shrink. I'm going to be using 2 kinds of heat shrink. One is for the ESC itself, and then this bigger one here is a 3/4 inch ESC. It's going to slip onto the arm and kind of hide some of the wires to give it a cleaner look. So when you're doing this ESC, you kind of have to do it in this order, otherwise things aren't going to work. I'll show you why in a little bit. Alright, so you're just going to slip these ESCs on like that. You're just going to put them on, but don't shrink them up yet until we verify the motor directions and everything in clean flight. Okay, so now that we have all our heat shrink in place, we can mount the landing gear. The landing gear that came with the QAV210 are these little, I don't know, these, I guess 10 millimeters standoffs, but these are terrible because they always fall off and you end up losing them, and then you can't really fly with just, missing landing gear because your quad won't stay still while you're the NACE is initiating the startup sequence. So I designed these landing gear right here. Each kit's gonna come with 4 of these sliders and a little bumper and all the hardware you need to mount the landing gear on here. So it's gonna come with 4 M3x10 screws, and these are for these. And then it's going to come with an M3x8, and that's for this little front bumper here. So when you mount it onto your standoffs, you use these M3x8s for that. and then it's gonna come with these little lock nuts. So when you mount this onto your landing gear, you don't have to worry about them ever coming off. So you just fit them into the little hexagon hole, and then you take one of the M3x10s and you put it through the hole, and then you just screw this part on, and then you screw this on. So by doing it this way, you don't ever have to worry about your landing gear falling off. So you have 4 of these on here. It's been working pretty well for me. So I'm just gonna put the rest of them on, and then we'll move on after that. Okay, so now that we have our landing gear installed, we can mount our motors and prepare them to be soldered onto the ESCs. But before I put the motors on, I'm just gonna put on the motor guards right here. If you're not using these, of course you can skip this section. So the motor guards just slip on just like that, and then they come with these M3x8 screws. If you're not using the motor guards, you should use M3x6 screws for these motors. I mean M3x5. Don't use M3x6 because you don't want to use a screw that's too long, because if you're using one that's too long, when you screw it in, the screw is going to touch the motor winding, and that's going to cause your motor to like twitch and overheat, and you don't want that. So we just mount the motors on here like this. So you don't have to put them on super tight right now. It's just kind of long enough to where you can measure the ESCs. But make sure you put at least 2 screws into the motor, because if you only put 1, the motor could be kind of crooked. And then when you measure out your, why is this not going in? And then when you measure out your motor wire, is not going to be long enough for the ESC. So I've got 2 in, and then I'm just going to do the same for everything else. Okay, so now that we have our motors mounted, we can start soldering the motors onto the ESCs. If you look on the diagram, motors 1 and 4, the wires are going to cross. So it's going to go, you're going to cross 2 of the 3. It doesn't matter which one you cross. It's like this, and then motors 2 and 3, they're just going to go straight across from pad to pad like this. But before you solder anything, it's a good idea to put some to pre-tin these ESC leads, since they didn't come pre-tinned. So just go ahead and cut your wires and then pre-tin the motor wires and the ESCs. Okay, so now that you have all your motors soldered onto your ESCs, don't shrink up the ESCs quite yet. Just pull them over the ESCs just to make sure the ESCs aren't touching the carbon fiber frame, because carbon fiber is conductive and you don't want it to touch the frame. So we're just going to cover the ESCs temporarily for now. Okay, so now we're gonna get ready to we're gonna prepare the battery cable to be mounted on the PDB. So make sure you put this little orange thing on there before you solder it on, because once you solder it on, you're not gonna be able to get this on. So we're just gonna measure out just a little bit of mesh. and then put your cable through the mesh. And then from here, you're just gonna put your heat shrink on both ends. So I like to put a little dab of super glue at the connector end of the heat shrink, so that way it makes sure the heat shrink doesn't slide all over the place when you have it on there. Just like that. Now you're gonna put the bottom one on. And then I'm just going to take a lighter and shrink up the ends. The lighter's about to die. And it's dead. Okay, so now I have my XT60 cable ready. Got the heat shrink on there, got the mesh, and then make sure you put this little orange thing on before you start soldering. This little orange thing is to protect the cable from the sharp edges on the top part of the frame. So this is something I forgot to show in my soldering video, so I'll show it now. Okay, so before I solder it onto the power distribution board, I like to put a little bit of my own solder onto the tip. Even though most of the XT60 cables come pre-tinned, I don't know what kind of solder they use, but it's like really hard to melt. So I figured that, well, I found that when I put my own solder on there, it's a lot easier to solder onto the power distribution board. So same thing, you want to coat the whole cable with solder and throughout the all the strands inside. Like that. And then I'm going to pre-tin my power distribution board with some solder also. Okay, so just make sure you're soldering the red lead to the positive and the black to the negative on their power distribution cable. So when you're soldering these, the solder is just like any other solder joint. I touch where the two joints meet, but on these big fat XT60 cables, I found that it's easier if you melt the solder on the PDB first and then just kind of let the heat flow over to the XT60 wire. So all you need is just a little bit of that melted, and then I kind of push it down like this, and then I just finish off the rest of the job. Kind of move it around, get the heat nice and distributed. You want the solder inside the XT60 cable to melt also. So just like that. And you can see the solder joint's nice and smooth. You don't need a lot of solder on this either. So same thing on this other side. I'm gonna heat it right here till you have a nice little bond. And then I'll change my position, kind of flatten it. You don't want to put your pressure here, because when the solder melts, you're gonna flatten the tip, and that gets really ugly. Just kind of move it around, get the heat everywhere. And you can see the solder is all nice and melted now. So nice. So there you go. Okay, so the last thing we need to put on the PDB is the VBAT cable for the OSDoge board. Since I'm using this little cheat sheet here, I'm just going to go ahead and mount it now, because because I know the exact length I need. But if you don't have this cheat sheet, you're gonna have to do this part after you have the OSDoge mounted on here. What you would do is mount your OSDoge and then just place your VBAT cable on here, and then you just kind of measure out how much cable you need, cut it, and then you solder. But since I already know how much I need, I'm just gonna go ahead and do it now. So I'm just gonna measure right here for the VBAT. So now I'm just gonna splice the ends here and then solder it onto the auxiliary 1. Alright, so this is what you need for the VBAT. This is gonna connect to your OSDoge board. Okay, so now we're gonna prepare the OSDoge to be mounted on our quad. The main purpose of the OSDoge board is to provide OSD on-screen display through your goggles. It'll show you things like RSSI, your battery voltage, flight time, you know, virtual horizon, your flight mode, things like that. But it also has some other great features. Since the ESCs we're using are opto, meaning there's no BEC to provide the 5 volts for the NACE32, the OSDoge has a 5 volt out right here that's going to connect to, so when we stack it up, when we stack up the board on top of the NACE32, it's going to stack like this. So the 5 volts are going to come in right here, ground 5 volt, to the number 6 right here, ground 5 volt, and then right here is going to stack to VBAT. This is going to provide a VBAT to the NACE32, and this will be for monitoring your battery voltage. And then right here, ground and VBAT, this will be, connect to this little wire we added on earlier. Okay, so we're going to start off by soldering on the 6-pin 90-degree header facing inside on the top of the board. This way, when you stack it on top of your NACE32 like this, you'll have easy access to these wires right here. I've seen some people install it with the NACE32 on top like this, but then when you try to access these cables, it's super hard to get to. So I like to put my OSD on top. So the same thing when you're soldering this, it doesn't matter if it sits flush. For the first solder, you're just going to tack it on and then just lightly push up, and then I just tap the solder and then it'll sit flush like that. And then for the VBAT, we're just going to use this 2-pin 90-degree header and put it where it says ground in VBAT. I'm just going to put it under the board facing in. And on this one, I like to put a little thing under it because it'll burn your table. Same thing on this, you just tack one. And you can see it's a little crooked, and then just push up. Make sure you're not touching the one you just soldered. And then now you got 2 headers that are perfectly seated. Now you can solder on the rest of the pins. Okay, so as you can see on the back of the OSDoge, you have all these little jumper blobs. These are settings for your battery, and then VTX and camera. So if on the first one, the battery select, if you're running a 4S, you want to put the blob on the left side where it says 12 volt regulated. And if you're running 3S, just put battery direct to 12 volt, and that'll be the blob on the right. And then also for your video transmitter, you got to figure out if your transmitter uses 5 volt or 12 volt. If it's 12, go on the left. If it's right, go on the right. And then a camera is 12 volt, it's default. So I'm going to be running 12 volt transmitter and 12 volt camera. So I'm just going to put a blob right here on the 12 volt video transmitter. And then I'll be running a 3S for the initial setup on this. So I'm just going to move the blob over to this side. I don't know if you can see that. Now we'll solder on the stacking pins for the NACE32. I like to create the stack away from the quad because then it's easier to solder the bottom of the male-female header pins. So I just put some M3x5 screws and then just put the standoffs on here real quick. And then you're going to take these male-female header pins and then just put them in together. You want to put this end into the header, and this part goes into the board. So the end with the little kind of cylinder thing goes into the board, and the cone shaped side goes into the header. So it's going to go in like that. And then you're going to put them right here. This is the 5 volt for the NACE32, and then another one for the TXRX, and then one more for the VBAT. Right there. And then you're just going to stack it up this way, line up the pin headers. And then I'll just put on one of these little hex nuts to hold it together while I solder it. Alright, and this is just one little extra thing I like to do to make sure the header pins are seated into the board. I take a little flat screwdriver and then I just push them in between. I don't know if you can see that. I'll push them into between and just kind of pry them apart just to make sure they're seated well. Do that for all of them. I don't know if you can see what I'm doing here. And then once you have that, you can solder them together. So that's it for the bottom. And for the top, I like to put it in the clamp because it's a little, because of that header pin down there, it's a little uneven. So that's it for the stack. So now we're going to mount the NACE32 and OSDoge onto the frame. So first what we're going to do is we're going to put these the ESC signal leads back into this little harness so we can put it on the NACE32. But when you're putting it in, make sure you put them into the correct hole. So our NACE32 is going to sit like this. So this is going to be signals 1. This is ESC 1 is going to connect to the ESC motor 1. 2, 3 is here, and then 4 will be here. So just make sure you have the wires connected into the correct holes. So I know my first one is going to go right here. signal 1, and this is 2. And 3. And then 4. And then once you have it, make sure your USB is pointing off to the left side, like this, and then you're just going to plug it in. And then it'll sit flush like this. Now it should be nice and neat. And then you're just going to put these little the standoffs that came with the OSDoge on here. And then you're gonna move your RX cable down here, because we're gonna have the D4R2 right here, and then your OSDoge is gonna have the USB facing forward. But before you put it on, make sure you put on your VBAT cable, and make sure you put the ground on the left and VBAT on the right. You don't want to hook this up backwards. That would be bad. So make sure you have it hooked in the correct way. And then you're just going to line up the pins and then just push on the board just like that. So if you didn't mount your VBAT earlier by using this little cheat sheet here, this is when you would measure out the VBAT cable. You plug it in to your VBAT, and then you kind of wire it under here, and then you just kind of measure how long you need, cut it, and then solder it on. Okay, so when we're building flying crashing quads, there's so many things that can go wrong. I like to eliminate as many as much room for error as possible. So on the D4R2, to put it in PPM mode, you have to put these little black jumper things on 3 and 4. But when I used to do that, these things always fall out, and then you might spend waste some time sitting there trying to troubleshoot it. So what I like to do is just permanently put a blob of solder across the 3 and 4 input leads. So just pull this little plastic thingy off, and then just open up this the back part, and then the input leads for 3 and 4 will be the one on the very left. So I just put a little blob of solder across these two. Now you can see there's a solder blob across them. Now I never have to worry about the jumpers falling off. And I've never been in a situation where I needed to do channels 3 and 4 separate, because I always run these in PPM anyway. And then one more thing I like to do is sometimes in my other quads, when I have these pins sticking out and then you like crash or something, these pins will move forward. And usually when I mount the D4R2, it's really close to the NACE32. So what happens when it crashes, it moves in, and all these little pins, they touch the NACE32. And I've had situations where it went forward and it shorted out my NACE32. So what I like to do is I like to just take a wire cutter and just cut off all the ones I'm not using. So I'm only going to be using the top row pins for ground, 5-volt, and signal channel 1, which is these top 3 pins right here. So all the other ones that I'm not using, I'm just going to take a wire cutter and just cut them off like that, and do the same for all of them. Just be careful when you're cutting these, because sometimes they'll fly out like little missiles. So when you're done, you'll end up with a blob across 3 and 4 and just the 3 pins that you'll need. So now once you got your solder blob put in there, you can put this cover back on. Just gonna do cover back up like this, and then I'm just gonna use this little D4R mount that we're gonna be using for our QAV210. So you're just gonna push these antennas through the little holes. And then once you have it in there, it'll sit nice and firm. You don't have to worry about it coming apart. Now we're going to mount the NACE32 onto the frame. Before we can do that, we have to mount these 35mm standoffs onto the frame. So just get the M3x5 or M3x6 and just mount the standoffs. One thing, when you're mounting the standoffs for the front right here, make sure your wires are on the outside of the standoff, because later when we mount the plates for the camera, if they're on the inside, they're gonna get chopped. And then for the front one, since we're using these little bumpers, use the included M3x8 instead of M3x5s, because use the regular ones, it's not going to fit. Okay, so now we have our standoffs on here. So this, the mount is just going to slide onto the rear standoffs right here through these little holes right here. And then just push it down. And then plug in your cable. Make sure you have it corrected. Make sure you have it plugged in correct. Your signal is going to be on the outside, and then your power is in the middle, and then ground is on that side. Like that, and then just push it down a little bit more. So it's just going to sit like that, nice and neat. So now we're ready to mount the FPV part. First part we're going to do is a camera. Okay, so the camera, you're going to use these little side plates that came with the QAV210. The way you use these is you just, you just line up the little hole right here. I like to use the middle hole. And then you're going to get these little flat screws that comes with the camera, and then just screw them into the side of the camera. And then once you have the screws in, you're gonna put the little tabs that are on the plate into these little holes on the frame, and then you're gonna use the wiring harness that came with the camera. And then you're just going to plug it in here, and then just measure out how much wire you need to reach the camera plug right here. But make sure you give it enough wire to where if you angle your camera like this, it's going to pull more wire. So I'd suggest measuring with your camera angle pointing up, and then you cut it right here. But I'm going to use a cheat sheet. So I got my FPV camera here. I'm going to line it up. Cut it off. And then you're just going to do the same thing with the video transmitter. The Lumenier transmitter, it comes with this harness right here. So it's going to come with a whole mess of wires. So the ones you need, see when you plug it in like this, so the ones you only need are these right here. If you have this little tab just flip it over. You're just gonna need the power, ground, and signal. These other ones you don't even need, so I'm just gonna clip it off. I'm gonna clip these off right here, and then I'm gonna remove these. Just take something sharp again, and then just lift up the tab, and then you can pull out the connectors. So this is all you need for the video transmitter, and then you would just plug it in. Do the same thing, just plug it in, and then mount it to where you think that you're gonna need, like this, and then just measure out your wire, but make sure you have enough to go back and then into the plug. I'm just gonna use my cheat sheet again. So here's my VTX, line it up. So now I'm going to show you how I make wiring harnesses for the VTX and the camera. If you don't have this tool right here, I'll put a link of this in my on the website. This is a wire crimping tool. I freaking love this thing because it saves you so much work, and it helps you make super clean wiring harnesses for the VTX and camera. So if you don't have this tool, you just get one of these little 3-pin servo connectors, cut it in half, and then you're just gonna have to splice your wires together, and then that way it can connect to the OSDoge, like right here. But I'm gonna show you how I use this thing to get super clean wiring harnesses. So I'll just do the camera first. First, I'm gonna put the mesh through it. This is just a regular, I think it's a 3 millimeter mesh or something. Alright, once you got it, just push it through. And then I'm just gonna snip a little bit of strip a little bit of the wire off. Just a tiny bit. Just make sure when you're doing this you don't cut the wire, because these wires are so tiny. So you're just gonna strip a tiny little bit off like that, and then I'm gonna use my wire crimper. So I've got these little connecting harnesses. I'll put the link for these where I got these on my website. They're just little tiny connectors. So I'm just gonna put one in here and just kind of clamp it down a little bit, and just to hold it. I'm gonna take the one that I just cut, and I'm gonna push it through just a little bit. It's in, you can just clamp it down, and this thing it'll stop. You'll see this little thing click up when it's ready, like that. And then now you got one done. So now you're just gonna do the same thing for all the other ones. So now once you have all the little connectors on the wires, you can push this heat shrink or the mesh up a little bit, and then I'll just feed the whoops, wrong end. I'll just put the heat shrink down the tube. And then I'm going to use these little 3-pin connectors. We took off the ESC. If you use 2 of them to cut off for the NACE 32, you should have 2 more, because there was 4 of them that came on the 4 ESCs. So I'm going to just use one of them for the camera, and just make sure, well, this is how I like to do it. I like to arrange the wires to where I have this ugly side of the connector down. So I'm going to plug it into the OSDoge. The camera is going to be on this side. So signal is going to be on the outside, power in the middle, and then ground is going to be that way. So it's just going to sit like this. So you can see I have signal, power, ground, and then I'm just going to push them into the connector. And then just use something sharp to poke them in until you feel a click. So there you have it, one perfect little connector for the camera. So I'm just going to do the same thing for the video transmitter. So when you're done, you should end up with two little harnesses like this, one for the VTX and one for the camera. And then from here, you're just going to plug this into the camera, and then these parts are going to go into the OSDoge, but I'm not going to do that yet. So that's pretty much it for part one of the build. Part one is more of the physical build, building the quad. In part two, I'll show you how to flash the OSDoge, and I'll show you a way to set up the OSDoge without needing the computer. You could do it through your goggles, and then we're gonna flash Betaflight onto our NACE32, calibrate our ESCs, make sure all our motors are running correctly. We're gonna bind the D4R2, program the Tyrannus, set up our RSSI and everything. So I hope you found this video helpful, and look out for part two of the video. Thanks for watching. Please don't forget to subscribe.